So I was having a discussion on YouTube with someone about some Bedini motors, and I was very skeptical about the whole over unity concept, and I thought I would run a little test myself. I took the schematic and the how-to build instructions that were provided on the website, and I put together one. And what I'm going to be doing is, I have my battery here that's being charged, and right now we can see the voltage is at 12.3 volts. This is going to be measuring the amperage going in, and my power supply is actually in place of the charging battery that would normally be providing the current in these setups, because it's really hard to tell what's going on sometimes when you have two different batteries of two different capacities. So if we turn it on, now I just wanted to show on this schematic, down here where it's showing this negative 12 volts, this is actually where I'm taking my ground for all of my measurements. So the oscilloscope ground and the ground showing the voltage on the meter is actually at this point, along with the ground that actually is referenced on the power supply. So that's why it's going to be showing over 20 volts, because it's actually these two. In here it's showing a battery, but my power supply and the battery in series. Just a still screenshot from the video. At 14.8 volts times 0.04 amps, I get 0.592 watts of power going in, and then on the output I get 27.16 times 0.004 amps, and I get 0.1 watts output. So that would be how you would calculate the efficiency from this system. And similar to what you see on a lot of these videos out there, is the voltage is slowly climbing up on the battery, and it is taking a charge, but we are getting 4 milliamps going into this battery, and the system providing it is outputting 40. Now if you're interested to see what kind of waveform this puts out when it's not under load, I'll turn it on. We're getting a maximum about 41.6 volts and a minimum of 16 volts. But again, the voltage has nothing, isn't telling you about the actual power output. And as soon as we connect our load, if we turn it back on, you can see that we basically get 28 volts steady, and that's because the battery itself is pulling down the voltage, and it's just trickling in a small amount of current. There really isn't even any pulsing going on, so I'm not sure if this would work to desulfate a battery, because it's just pretty much a steady charge going into it. I do have the averaging on. If we try it one more time and I take the averaging off to actually see what kind of pulsing we get. Now I stand corrected, it definitely does pulse. in a very short period of time. We're in 100 nanosecond divisions here, but it does go up to 85.6 volts. So I haven't played with desulfating batteries using a pulse technique before. I've heard some people have awesome luck with it. I've heard some people say it's a scam, but unless I've tried it myself, I really can't say otherwise. So you might actually be able to use a small relay like this in order to desulfate a battery, but the idea that you would get more power out than put in is completely false from everything I'm seeing. And hopefully you found this interesting,